Okay, so as we were discussing about the Bitcoin, we were talking about the Bitcoin structure of the Bitcoin. Another, okay. So whatever the previous class which we missed, I just recorded and posted on the canvas. Please go through that. Yeah. Okay, so in that the major task which so is the Bitcoin block structure. It is having two fields. One is the header field, another one is the transaction field. So the header field, we have seen to identify any block that is depends upon the previous hash value is used to create the new block that comes under the hash field. I mean the header field of that. And second most important part of the Bitcoin is the transaction part. So in that transaction, as we said, any user in the network, Bitcoin network, if they want to do some transactions, so then their transactions will be signed first by using some software we call the wallet software. We'll talk about this wallet software in details in later. So then once that transaction is signed, then those transactions can be broadcasted in the Bitcoin network so that whoever the mining taskers are there, they can get those transactions and trying to combine all the collected transactions in one block and try to what you call broadcast that block among the network so that when every transaction confirmation comes from the nodes from the in the network, then that block will be added to the blockchain. So that is what we observed. So what is most important in these transactions of your block is, as we said, the user can create the coins or user can spend those coins. Okay, so as we discussed, it is like bank transactions. The user can deposit the money, means creating the coins, and the money can be spent for their own use purpose. That is the spending the money type. So in this transaction also you will have those kind of activities. So we call those activities as or any transaction in the Bitcoin can be defined as your input and the output. The transactions in the Bitcoin defined as your input and the output. So in this, what happens? The transactions are at the core of this Bitcoin ecosystem. So these transactions can be as simple as just sending some Bitcoins to a Bitcoin address, or it can be quite complex depending on the requirement. So each transaction in the Bitcoin, uh, so that is the composed of at least one input and one output each transaction. The combination of one input and one output will be there. So inputs can be thought of as your coins being spent that have been created in a previous transaction, and output as coins being created. So if a transaction is minting, suppose new coins, then suppose in the first transaction, suppose of any user or any Bitcoin peer in the network, you will find the input as well as the output. So input means you're going to spending the money. Output means you are going to create spending the coins. Output means you are going to create the coins. So that means what? In every transaction, suppose in this Bitcoin, suppose a user is wants to deposit the $100, suppose, or $100 worth Bitcoins, then that Bitcoin will be first created in transaction 0. So when creating, first the user, creating these coins, it will be with the help of, we call that as your output, Bitcoin transaction output. So these 100, the dollars or 100 Bitcoin transaction can be like, 40 coins will be created in one output and then 60 coins will be created. Means doing to creating the what you call the bitcoins. And after that, the user can try to spend these coins. Maybe they can send to other users, or they can transfer these to other users. So when they are trying to send these coins to other users, we call that as your input. That is spending. So that means what? In this zeroth transaction, if from output 1 doing the transaction means the whatever created here, suppose the 40 bitcoins which are created here, those 40 bitcoins are now ready to spend. Whatever the 60 bitcoins are created or deposited, we can say, they are ready to spend now. So when you are transferring this to spend to doing the transactions, then that transactions maybe will be taken it as whatever the available coins are there, they will be taken for spending purpose. We call that as your input. We call this input. So for this, from this 40 Bitcoin, you can create some transactions there. So how you are going to spending this? Whether you are going to spending in a whole at a time, or you are going to spend in a two different way. So out of 40, suppose in this transaction, out of 40 bitcoins, if I want to spend only the 30 bitcoin, suppose 30 bitcoin. So 30 bitcoin will be, means out of 40, 10 bitcoins were spent, remaining are 30 bitcoin that will be created. So now these 30 coins can be used for another transactions. So as you see, first you are depositing. Depositing means you are creating coins. You are creating means we use the function. In Bitcoin transaction, use the functions output. For spending, that means you are withdrawing. You are taking input for spending. So input coin will be there. So in this case, when creating, you don't need, if a transaction is minting a new coin, then there is no input, only creating, right? So, and therefore, no signature is needed because you are creating your Bitcoin and keeping with you only. You are not doing any transactions, correct? So, when there is no input, when you are not supposed to send, then you don't need to do the signature process, right? So then if a transaction is sent coins to some other users, then it needs to be signed by the sender with their private key, and a reference is also required to previous transaction in order to show the origin of your coin, who is sending that coin. So the unspent transaction outputs represents in the Satoshi of your Namakoto Bitcoin case. So the transactions are not encrypted basically. Any transactions, they are not encrypting. Okay. Instead of that, they are without encrypting and are just publicly visible in the blockchain. So the blocks are made up of your transactions, and these can be viewed using any online blockchain explorer. Okay. So that the transaction, suppose the 30 coins are there in the transaction 1 available, and 50 coins are available, means in transaction 1 10 bitcoins are spent, in transaction 2 10 bitcoins are spent. So the remaining bitcoins in transaction 1 is 30, and remaining bitcoin in transaction 2 is 50. So now they are ready for spend. So you can spend those. So when you are ready to spend, then another transaction will be take place. In every spending, another transaction takes place. So in that transaction, how much you are spending and whatever the remaining is there, remaining bitcoins are known as your output function. So you can, in this transaction, suppose spend 0 coins. So still you have the 20 coins, but this 30 bitcoins are separated to spend 10 coins for one transaction and 20 coins for another transaction. Similarly here, if you want to spend these 50 bitcoins into a single transaction or multiple transactions, I mean single way or multiple way. So that means if your 50 bitcoins are supposed to spend 10 bitcoins for pizza and 10 bitcoins for your burger, suppose, for example, and the remaining and what you call the remaining 30, suppose for the any drinks. So then you will have three outputs. You will have three outputs. So output 1, your output 2, and output 3. So that means you are spending 0 in this transaction, but you have created your bitcoins into separate cases. Okay. Yes, please.
So we can have a transaction where the purpose is just to split them up so that they can be used in separate transactions later.
Yeah, it is possible because, as you said, if Tom deposited some amount into the account,
yeah.
So entire amount he cannot spend at a time, right? He may in every user's in mind thinks that $10 for this travel purpose, $10 for food purpose, like that. So you are dividing that. So if you recall your bank accounts, there you can find checking account and saving account. So you can transfer the amount from checking to saving, saving to checking. Yeah. So this is what. So what this slide means to say is, in every transaction, whether you are spending or whether you are creating the coin, right? And another one is when you are creating the coin, you don't need to do any digital signature operations because you are creating and keeping with you only. But when you are spending, you need to do the digital transaction. That means digital signature operation is required in that case. So here, when in the Bitcoin, instead of the Bitcoin, they use the scripting language or scripts for doing the transactions. So how Bob will, suppose the Alice wants to do transaction with the Bob, the Alice to Bob, how Bob will verify that this transaction is actually originated from the Alice. So for that verification, if you recall the cryptographic primitives, we use the Alice send the public key of Alice along with the transaction. So that transaction is signed by the private key of your Alice, and along with that signature, digital signature, Alice sends the public key. So by using this public key, Bob can verify, yeah, this is from the, because that public key is a pair of the private key of your Alice. So only the Bob can verify that. But in that case, what happens? This is generally we use in the digital signature verification. But in Bitcoin, instead of the public keys and the digital signature, Bitcoin use the scripts. So how it use the scripts means the Bitcoin indeed transfer the script instead of this public key of your, the signature and the public key of your Alice. So how it will be sent? Instead of sending the public key and the digital signature, the script is used, that script public key and script signature. Script public key and script signature. So in this script public key and the signature, as mentioned in the previous lecture video, that they're using the Turing complete language. In this Turing complete language, use the script. So script for public key, one script will be there, and for digital signature, script will be there. So what is this? In every transaction, as we are saying, that there is one input and one output. One or more output will be there, but one input will be there. Okay? Input for spending and output for creating. So now script public. So public key of your Alice is used for the identification purpose. So for what? To create the Bitcoins, script public key is used. And when you are doing transactions, you are spending, Then for verification, digital signature is required. So script sign is used for your input purpose, and the output transaction of your Bitcoin is your script public key. So Bob can spend the bitcoins. Bob can spend the bitcoins of your the alley transaction only if both the scripts, your input and output scripts, return the true value after the execution of these scripts. True value means the verification will be done. That means what? When true value comes, that public key means suppose Alice created 10 coins and those 10 coins are transferred to your Bob. So when the digital verification done, in that digital verification, if 10 coins are there, then it returns as your true. If, if instead of 10 coins, if nothing is there, then it gives the result 0. Because if there is no coins, then how Bob can spend it? So when a transaction is received by the Bob, Bob will try to execute these two functions. If both are executed as true, then Bob is ready to spend those coins, transactions. So in this Bitcoin script, with every transaction, the Bob must provide the public key that is hashed when it created the new transaction. So that yields the address of your Bob, which is embedded in the script, is one. And second means when the key coins are created by the Bob, Bob must use the public key to create the coins. And when the transaction happens, spending those coins, then the signature is provided. So that signature provides the ownership of the private key that is corresponding to the public key of your Bob. So in this case, as we are saying that the bitcoins, they use the scripting language. They use the scripting language. So in this script language, what is the Bitcoin use for transaction inputs. Input means spending. For spending purpose, signature is required. For creation purpose, it uses its own public key to create the coins. Okay. So these are two part of your Bitcoin script. So this Bitcoin use a simple stack-based language. It uses the stack-based language. So in this stack-based language, we also called it as your scripts. So to describe how this Bitcoin can be spent and transferred, so this script language is used. So it is not Turing complete and has no loops to avoid any understanding or undesirable effects of long running or the hung scripts on the Bitcoin network. So this scripting language is based on the forth-like syntax and uses a reverse polishing notation in which every operand is followed by its operators. So if you talk about the scripts, it will have the instructions first. Instructions are, we call it as your operation code. So every instruction or opcode followed by the operands. To do any of the transactions. So we call that as it is, and this one is evaluated, the opcode and your operands will be evaluated from left to right using the last in first out operation. So that is the basic operation of your stack. So it will push the instructions, the operands, then the instruction will be pushed. Once the instruction is available in the stack, then the instruction as well as, the opcode as well as your operands will be pop up and do the operation. That means what? Simply, suppose if you have the instruction like add the R1, R2, suppose. So we call this as your opcode, and this one is your source 1, this one is your source 2. When you do the stack operation, then the operands will be pushed first into the stack, like R2, then the second operand R1, then the opcode will be pushed into your stack, that is your add. So when top of the stack is the opcode, then it pop up the operation and do the addition of these two numbers, and the result will be again push the you do the operation and produce the result, and that result will be pushed back into your stack. So the scripts uses the various operation codes, but in this the Bitcoin transaction script is evaluated by combining these scripts, that the script sign and your script public key. So as said, this script sign is the unlocking script. Unlocking means you are ready to spend the money, and your script public is used for your the locking purpose, means you are creating the coins. So the commonly used operation codes in this for the transaction output is, you will find the OP, the opcode for duplicate, opcode of hashing, opcode of your evaluation verification, opcode of your checking, and for scripting, it is using the digital signature, means the digest is used for verification purpose. So we'll see this one by one. When you are having this, the operation code of your DUP is the command or instruction, we can say. This is one instruction. The instruction of your script language, which will be executed by your sender as well as your receiver, or we can say the creator and your the spender also. So this DUP operation, DUP means it gives the this is the duplicate the top item in the stack. This instruction, when this instruction is issued, it duplicate the top of the stack. And if you have the instruction OP checking, suppose, so OP check sign it is. So this takes a public key and signature and validates the signature of the hash of the transaction. If it matches, then true is the pushed onto the stack, otherwise false will be pushed onto the stack. And you will have the equal the verification. So this is the same as your simple equal or equal verification operation without this verified. You will have that is same as your equal also. So in this instruction, it says this instruction indicates that this is the same, but it verifies the framework that whether the values are equal or not from your script sign and your script the public key. So another important one is we are using the hash instruction. So the operation code of your hash 160. Why it is? As we said that in the Bitcoin transaction, the address of your blocks are hashed twice. The transactions are hashed twice. First, it is hashed with the SHA 256. Then it will be hashed with the write MD 160. So it will give the digest size of your 160. So the input is hashed twice as said, and then it will generate a 160 bit size of your hash code. This hash code. So these are the, few commands are the most commonly used operation codes in this Bitcoin scripts. So how this operation is taking place means, as we said, it will take two inputs. Bitcoin script takes two inputs. So one is script public, another one is script signature. So in script public, when you are trying to create the coin, you are using the to duplicate this public key on top of the stack. You are using the instruction that OPDUP, and then use that public key to create the hash value. Use that public key to create the hash value, that is 160 digest, and then that digest is used for the push that digest value or public key hash value into your stack, and after that that hash value will be used for checking whether the verification is whether it is equal or not. So that means what? The this term is 1 if the inputs are exactly equal. If this term is 1 means if the inputs are equal, if otherwise it will give the 0. And then the another instruction is used, that is your check the signature, the operation code which is used to check the signature. This is it takes the public key. This instruction takes the public key and the signature, public key and the signature, and it validates the signature of the hash of the transaction, and if it is matches then gives the true value, if it is not matches then it gives the false value. So initially in the stack operation, you don't the stack is empty, so both the scripts, it is your script public key and your script signature, okay, so both are combined into and input followed by the output, input followed by the output. So what is the input? Input is your public key because you are going to create the coins, followed by output, input is your signature followed by your the public key for spending. So what is there in the inputs? It is going to spend money, so script signature, it's sign followed by your public key. So in that case, it will find in the script sign, you will have the signature as well as the public key. That followed by your script public. In the script public, the sign is your input. That means you are spending, and it is followed by your output. In the output, first operation is your OPDO, second one is your hash, third one is your push the hash into your stack. Next step is doing the verification that the equal values are there or not, fourth, and then you will have the fifth, you will get the check. So in that way, the creator will follow this. Yes, please.
I apologize. I think I might have missed something. For script upkey, is that like a function definition that's saying we're going to do all of these operations?
Yes, yes. In that scripting language, it is like what you call the structure definition.
So the next time script upkey
Yeah.
is mentioned, I'm going to do all of those operations.
Yes.
In that order, and when we have the upkey hash like data section there, I assume that's saying that hey, because I've named something over, just below.
No, these are the instructions, standard common instructions which used in the scripting language.
Okay.
So like in C language, what you write to declare any integer. Yeah. What is the common structure that you write? INT. Yeah. Similarly, in this, if you write any functions, these are some common standard functions we call the operations, which are used in the scripting. Because when you are writing code, you need to write the code in same functions you need to use. Okay. So as said initially, the stack is empty. but both the scripts are combined. The scripts are combined, so the input followed by the output. So what happens? First, it goes the input. Okay, so that input followed by the output. If you see, you will write the input which are used for spend. So input means your script sign. In script sign, what are the instructions? You are having first sign followed by public key, and after that it will followed by the next instruction of your public key, right? So that you will get the input followed by public key. Then the top of the stack, the next instruction is, the operation is duplicate the top of the stack. Duplicate the top of the stack. So when you are using this duplicate the top of the stack means, what is the top of the stack now? Public key. So now use this public key to create the coins. So this public key will be used for the hashing purpose. Okay. So it is one more copy is pushing into the stack. That is, the instruction is OP, means operation code of the script says that duplicate the top of the stack. So now top of the stack is public key, right? Top of your stack. Now this public key is duplicated in the stack. Okay. So then it goes to, so top of the stack is duplicated. So now next it is going to execute the next operation. What is the next operation? Perform the hash. Okay. So now hash function means how it is performing. It do two operations. Hash. First, this public key is hashed with your SHA-256, followed by whatever the digest comes from this. The first hash, the input of this one is public key, right? Public key. Then it will give digest. That digest is again hashed by your the RIPE MD 160 algorithm. So it will give the 160 length digest. Okay. So it performs two operations, two-step operations. So top of the stack item is hashed with your the RIP MD 160 hashing. Okay. So now the hash value. So after that, what is the instruction? The instruction followed by push that key hash into the stack. So your stack is pushed into that. So your top of the stack will be the push hash key. So the constant is pushed into the stack. Which constant? Constant means the digest here. That will be pushed into the stack. So that public key hash value, the digest value will be pushed into the stack. And after that, it is going to execute the next instruction is verify that stack. So that is operation, whether the two inputs are same or not. So the equality checked between the top two items in the stack. So what is the equality will be checked? How this equality will be checked then? This will be popped out, this will be popped out, and both are going to be compared. When they are matching, it will give the result true. If they are not matching, the signature is, when they are matching, the signature is checked based on the top of two stack items. If they are matching, it gives true. If they are not matching, it gives false. So there, what is happening? First, coins are created. Then you are spending that coin. When you are spending that coin, you are along with the coins transaction, you are sending the public key of your sender. So that public key is verified by the signature now. If it is matching, that means you are able to spend the money. You are able to spend the money. So that is, in Bitcoin script instructions, there are total 256 opcodes are there. There are 256 operation codes are there. So these operation codes, they can. So, but after that, 15 operation codes, the 15 operation codes are disabled, and 75 codes are reserved. So remaining codes are basically used for your Bitcoin script instructions for the spending purpose. So what are those operation codes? Means your arithmetic operations. So arithmetic operations that covers, as you know, the addition, subtraction, multiplication, or your division. These operation codes are used. Okay. Addition means simply you can say the creating the coins. Subtraction means when you are spending, you are removing those coins. Multiplication means when you get multiple transactions, that operations will be used. And it also uses the conditional instructions. So what are the conditional instructions? Can anyone tell, please? Conditional instructions. Hmm.
Greater than?
Yeah, greater than or less than or
Greater
equals.
or less than?
Yeah. So before spending, you are giving the condition. If the coins, created coins and received coins are matching, then only you are able to create. I mean, spend those coins. So that the if-then conditions will be there. Other than these 15 plus your the 75 reserved ones. So then you are having the logical operators. So in logical operators, the logical operations. What are the logical operations that you know? Yeah,
Or, and, else, or.
correct. And operations, the logical and or operation, or your XOR operation. Yeah, you will have the NOT operation, NAND operation. So like that, you will have the multiple logical operations and the data handling instructions. So these data handling instructions like doing the duplicate the data. Here the public key is duplicated, right? And you will have the cryptographic operations then. So the cryptographic operations are such as your hash functions, as we use the SH256, and your the RIPEMD 160 hash functions. Then digital signature verification and multi-signature verifications. If multiple transactions are there, multi-signature verifications. So these are the Bitcoin basic scripting instructions: arithmetic, conditional instructions, logical instructions, and data handling instruction for duplicating and those things, and most importantly, the cryptographic operations. So for inserting a Bitcoin, into your network, so what is the Bitcoin script is used means that is the provable and the unspendable, or the pronoun the output, we can say we are going to create the new coins. In that case, what we are saying, we are going to use the script public key for creating Bitcoin, or simply giving the name, we can say that. And then the operation which it gives is the operation when the checking the inputs, two inputs on top of your stack, it will give the operation return value. If the operation return value is 0 or more, than that, 0 will be there. 0 means if it is matching, I mean, if it gives returns 1 means it is true. If it is 0 means it is false. Or you, in your writing, when you are writing the code, you may set that return 0, that means it is true. Return 1, that means it is false. So anyone can spend this output the created bitcoins by using their public key and their digital signature. So digital signature for your verification purpose, and this in this digital signature, what will be the output that can be expected means the operation must be true. So here the link is given to get more understanding about the script and what are the what are the basic structure of those creating the coin script. Please go through this link, this. Okay, and then freezing the funds until a time in the future. So here it gives your conditional instructions. Conditional instructions. So in these conditional instructions, what happens? You are freezing some time, means up to this time don't spend this coin, and after this time you can spend this coin, right? So with the script which is used for this is you are going to create the coin first, so that is the output, and there you are giving the expiry time. After that expiry time, the remaining instructions in the script will be executed. Remaining instruction. That means the first instruction is your expiry time. Suppose giving that expiry time is suppose the 4th, the October 4th, 2023, and if that is if the Bitcoin is created today, suppose, but that will not be available to spend. It will be freezed up to this date. And after that, once this date is expired, means this instruction is executed. Once it is executed, then the Bitcoin start executing, creating the coin by the operation of your check, the lock it, time, and verify. Means you are going to locking it, creating it. Then to create the coins, you are doing the duplicate one, and you are using the other operation same as what we discussed right now. So that is the inserting the Bitcoin with conditions to make it freezing funds until a time in the future. So for that the scripting code is this. Okay. And so as we said that Bitcoin is an application of your blockchain technology. So that blockchain technology, we said that blockchain technology is a peer-to-peer network technology, distributed network technology, or ledger-based network technology, right? So Bitcoin is a peer-to-peer network, it is. That means every node in the network connected with every other node. Every node in the network connected with every other node. So an ad hoc network, this is an ad hoc network, means why we say this is as ad hoc network. Bitcoin is peer-to-peer network, and ad hoc network means suppose at some time, let us assume that at time t1 there are 3 nodes, Bitcoin nodes in the network, that is Bitcoin node 1, your Bitcoin node 2, your Bitcoin node 3, suppose they are connected to each other, so it is a peer-to-peer network. At time 2, some another node, another 2 nodes, suppose they also join this network. They also join this network. Let us assume B1, B2, B3, B4, and suppose B5. So they are also joined in this network, and they also connected to peer-to-peer connection here. So here the topology of this network is 3 nodes topology. But whereas here it is a 5 nodes topology. So topology is dynamically changing. So that's why we called any node can join at any time, or any node can leave the network at any time. So we called it as your ad hoc networks with a random topology. There is no fixed topology in this. So Bitcoin, the protocol that runs on the TCP port number, the port number is 8333 port number is used. So this, because as we know, to establish a connection between one Bitcoin node to another Bitcoin node, suppose Bitcoin 2, to establish a connection TCP connection between these two, they must require the port numbers. So here we are using the TCP port. TCP port. Why? If you talk about the TCP IP suite, in TCP IP suite, can you tell me that what are the different layers exist in TCP IP? Yeah. Mm. Mm. So I'll just recall your mind. First one is your application layer, right? Application layer followed by your transport layer, which is followed by your internet layer, which is followed by your data link layer. Data link layer, and which is followed by your physical layer. Which is followed by your physical layer. So, if you talk about internet layer or your network layer and your data link layer and physical layer, they are connected physically. These layers are connected physically to each other in peer-to-peer network. But whereas the upper layer, TCP layer and the application layer, we call them as they logically connects to each other. Logically connects to each other means if sender is using FTP, suppose application, receiver also use the FTP. If sender is using HTTP, suppose, receiver also use the HTTP. If sender is using DNS application, receiver also use the DNS application. So that's the one. So in that, to establish this virtual connection, the virtual or logical connection, we say logical connection, it uses the Bitcoin TCP network uses the TCP IP suite. In TCP IP suite, it uses the transport layer. So in transport layer, there will be port numbers. Like for example, I just give the example. The port number 22 that will be used for your secure connection of your SSH, or 23 for telnet purpose. So different port numbers use. If port number 80 means your HTTP, port number 443 means your HTTPS connections. So like that, to establish a connection in Bitcoin network, it uses the TCP port number 8333, that is a secure connection which is used to establish the logical connection between B1 and B2 in the network. So all nodes that are the users in this Bitcoin network are treated equally, as we discussed. So everyone is the owner. No single owner for any copy of the data. So new nodes can join at any time, and non-responding nodes are removed from your 3 hours. In Bitcoin, the condition is if the nodes which are participated in that Bitcoin network, if they are not responding for any transactions, then they will be removed automatically after 3 hours. So connection is disconnected by following your TCP3 handshaking connection termination process. So this is the example how the new users can join in the Bitcoin peer-to-peer network. So now we have the 8 users are there in this Bitcoin network. So these user, if any new user wants to join in this network at any time, then this new user will send a request to any existing user in that network. Just give me the address of the node. So then this seed node, any of the new node which is there, that node try to send a address list. Address list means these are the nodes. Every node is identified with this node's header. In that header, you are having the hash values, that is the address. So that address list will be first, the request will be sent by your the new joining node. Then the list of addresses which are available with this node will send to your new joining node. By using those nodes, so this node is having the addresses of this node and this node along with this node. So three addresses will be there in that address list. By using those three addresses, the new node will try to connect with these three nodes because their addresses are known. And after that, from there, it can start doing the transactions. It gets the most recent blockchain ledger from these nodes. One copy from this node, one copy from this node, one copy from this node. So then, as is joined, newly joined in this network, it is also having the updated copy of your block. That block is having transactions. So the most recent blockchain block is there. Then it start doing its transactions. So to start doing the transactions, what it will do? It will go with the output first. So output function, that means it start creating the coins, and then you try to do the input function, spending the coins in the network. So this transaction in a Bitcoin network, as we said, if any new user wants to join, always join her Bitcoin network by opening her applet, and on the virtual machine or any the what you call closed network, we talk about that when we permissioned model and the permissionless model. There we'll discuss more about these applets. So Alice makes a transaction to Bob. By doing that transaction, by sending 10 bitcoins. So then Alice includes the script with the transactions. Which script? Script public and script signature. So then Alice broadcasts this transaction in the Bitcoin network. Then upon receiving that transaction, upon receiving the transaction in the network, it is using a flooding algorithm in the network so that that transaction can be flooded to every node in the network. The transaction is available to every node in the network. So that the transaction is from Alice to Bob. Alice is sending 10 coins to Bob. This is a new transaction. That new transaction is broadcasted in the network, so it will reach to every node in the network. So upon receiving this, what you call the transactions, if any of these nodes suppose doing the mining, so they can validate this transaction by doing the signature verification. Okay. So after that, once the transaction is validated, then that verified transaction will be flooded among other users in the network. Other users in the network. So that valid transaction will be, I have already seen the transaction, if anyone is already doing that. So once the transactions are validated, then what happens? It will create any miner. Suppose if this node is the mining node, that mining node will try to create a block. In that block, you are having the header. So header creating from the previous block, it used the hash of previous block to create the new hash. And these new transaction, that is Alice to Bob, giving the bitcoins of your 10 will be added in the transaction. Okay, with this, suppose this is transaction X block, N block is there. So transaction N plus this transaction is added, and that new block will be broadcasted among the network once it is verified. And if this user's block is accepted by every user, then he will get the reward. For that creating transaction or doing the mining. So which transaction should you relay in this case? So the transaction is valid with the current blockchain. So there should not be any conflict, or there should not be any double spending in that. So without conflict and without double spending, if any new transaction is there in the current blockchain, that will be relayed. So the script matches with a pre-given set of whitelist scripts that avoid the unusual scripts and avoid the infinity loops to execute those scripts on the machine. So that does not conflict with other transactions, so that I have relayed after getting the blockchain update, so that will avoid the double spending of that transaction. So this transaction flooding in the Bitcoin, as said, the transaction Alice to Bob with 10 coins and some C to D of 20 transactions. Okay, so because the after Alice, another the users C is doing some transaction with Bitcoin, that will also flooded in the network. So like that, if there are n number of users, if they are doing the n number of transactions, so those n number of transactions will be flooded in the network, and every transaction will be received by every other node in the network. So different nodes may have the different transaction pools. So accept the first transaction that you have heard, and if you are having duplicate transactions, you can ignore that. So accept the first transactions that you have heard, and then collect all those transactions, and to get any reward point, the miners will receive and keep all those transactions with them to create a new block in that. So the miners collects all these transactions and flood and start mining of your the collected transactions as a block. And if that block is accepted by every node, means suppose if this X node is received a new block which is created by this miner, in that block it is having the block hash and transactions. So these transactions compare with the existing block, the hash, and having the transactions of existing sort of pre-transactions, let us say. When it is comparing, if these transactions are suppose, if these new transactions are suppose more than the pre-existing, that means it is having a new information. So this user will accept this block and you make this block as your updated block. The same work done by every other node in the network. So here the miners are creating the blocks. So this miner created the block X, suppose. This miner created the block Y. This miner created the block, suppose Z. So every node will receive block X, block Y, and block Z. So this will be received by every node in the network. So then these nodes, they'll try to compare which block is having the most updated transactions or more transactions. So those blocks will be accepted and remaining blocks are simply discarded. So this block created by this user, so the reward will be given to this user. Okay, so that is the miner who solved the puzzle first, means who collect all the transactions and doing the verification whether transactions are confirmed or not, and after that doing mining, that the solving the puzzle and generate a new block, and that new block will be broadcasted, flood that blockchain within the new block including which is included, and that will be received by every other users. So multiple miners can mine the new block, but simultaneously or in a near identity time, but only one users will get the Bitcoin, I mean the new block, and they will get the reward of some Bitcoins for transactions. And because every miner, they use their computer resources, right? Like their memory, the processor, and their energy. So for that, they will get some reward from every node in whoever participated in the network. So like that, the block propagation that accept the longest chain as set. The block propagation longest chain. The first block, from that block, the miners created, suppose, okay, with the new transactions, block 2 and block 3 is created, and from there your blocks, the 4, 5, 6 is created, but after that no other blocks are created from this 4 and 6. So the longest chain is used to create the new blocks, and shortest chains are, they are discarded from the network. Okay. So the block propagation that accepts one of the longest chain as said. So the accidentally folks, the occur relays on the, even if they occur, eventually only one becomes the part of the longest chain. Only one becomes the, because this, at this level the users may have block 6, block 4, block 5 having the same length of chain, but they can choose any one to create new one. At this stage, only one block is there. At this stage, two blocks are there. Either go by either this block or this block. At this there, three blocks are there. Blockchain longest. So it can pick the longest one. So there are the intentional forks of two types, that hard forks and your soft forks in the network, to come up with the new versions like Bitcoin Cash, etc., to upgrade the software versions. And will be further, we will discuss this during our lecture sessions when we talk more about the consensus, whether it is the distributed consensus, private consensus, and the public consensus, and semi-private and semi-public consensus. When we talk about that, we'll discuss more about this. So, which block to relay as we discussed? So, block contains the correct hash based on the existing blockchain. That means new block, whether new block will be accepted or not, means if that new block is created based on the existing previous block. Because previous block a hash only used to create the new block, right? If it is matching, then that block will be relayed and accepted. So all the transactions inside the block are valid. So then it will be relayed, and it checks the scripts to check whether they are valid or not. So the script change means you are going to do the script signature. Script signature code will be executed to check whether all the transactions are valid or not, and then validate the existing blockchain. Once their script check is true, then that block will be validated and add to your existing block to create the new block of your blockchain. So the block is included in the current longest chain that do not relay the forks of them. So the block propagation latency in Bitcoin network, it takes the mean time of your 12.6 seconds for the propagation latency. In 12.6 seconds, every block which is created that can be flooded in the network, which is the 95% of nodes that can see the new block within the 40 seconds. So this is what the result given by a author, Dr. Christian, that article which was published in 2013 in IEEE International Conference. So as says that within the 40 seconds, within 40 seconds, most of the 95% of your users, they can see the newly propagated the block. So in Bitcoin, the beginning, as we said, just to recall, it is a decentralized digital currency. So no central authority is there. It has two broad operations. One is transaction management and your money issue part. In regulatory, it depends on the different applications. So this Bitcoin basis is the, as we discussed, that creation of coins and then spending that particular Bitcoin in the network. So in creation of coins, we are using the scripting language. Okay. So maximum, the number of bitcoins generated per block is a set of you are decreasing dramatically with the 50% redundancy for 2100 blocks or approximately in 4 years. So for more information regarding this, please go through this channel. So with this, I would like to stop the session. So these are the basic blockchain elements, the generic elements and blockchain structure, and the application of blockchain is Bitcoin, their structure, and the Bitcoin which is doing the transaction verification using the scripting languages. Okay. Yeah, so that's all from my side.